Okay, so guys, we can probably start. Um, we finished last time with a practical that we did not correct, right? Good. So let's start by like refreshing some memories of what happened last week with like the correction of this last part of the practical exercises. So we were looking at data classes. With yes.
Do you mind if we just
Oh no. Sure.
are we recording?
Yes. Yeah. Thanks for the reminder. Okay. Can everyone see and read the screen also from? Maybe okay. I'll make it a bit bigger. Okay. So yes, we were talking about lists, dictionaries, tuples, and sets. We already did in the classroom the practical on lists. So let's have a look at the exercise on dictionaries. So just as a brief reminders, dictionaries were this data collector where we can store stuff, we can store variables, giving them a name. So we can access values that are stored inside the dictionary using some keywords. And in this case, the exercise was asking you to create a dictionary of word length, where the keys of the dictionaries would be the words, and the value that would be stored for each one of those keywords would be the length of those words. So the idea was did we already corrected this one maybe? Maybe we, well, doesn't matter. We will just refresh the concept of dictionaries. So one option would be like, and we could manually count this word is like, I don't know, 1, 2, 3, 4, 5, 6 characters, and we would put something like this. But actually the idea was we already had this word list variable that was a list containing several words. And so what I wanted you to do was to use this word lists for using like individual words as the keywords. Yes?
Can you zoom in a bit?
Oh yes, I will. And remember how to compute the length of a string with the length function. And so this would be, this would be keyword, like the actual word. Remember that when we do word list 0, we are actually like, this is the same as using, oh, I have not defined this. Sorry, I have to run the notebook from the beginning. Okay, so word list 0 was de. And so writing word list 0 is the same as writing the string de. And then length of that would be, like in this case, would be 3 and whatever. Then you can put word list 1, etc. Actually, probably we already corrected this one, but doesn't matter. Okay, so then we were looking at tuples, and as a brief reminder, tuples are similar to lists, but are data containers that we cannot change in their length. We cannot modify the content, and we cannot add new elements to it. And here I was asking you to just convert this word list to a tuple, and the easy way to do that would be just call the tuple function that converts something that can be converted in a tuple to a tuple. You can see like the different subtle is just before we were having square brackets, and now we have round brackets when we print it. But then the big difference is that if we assign this to, let's say, word tuple, the big difference is that if we now try to change, you remember that we could, for lists, we could do something like this for lists. If we try to do it with tuple, we cannot because tuples are unchangeable. Okay. And then there were a couple of exercises on sets, which are this interesting data collector type that represents ensembles of objects with no ordering. And the useful things about sets is that like they care just about the individual, like identity of individual objects. So for example, if we want to compare to groups of things, but we do not care about the order of the things. Just imagine that for whatever reason, you have a collection of numbers and that you put in a list, and another collection of numbers that you put in another list. And you want to see whether the numbers in the two lists are the same. But the two lists are obviously not the same because we can already see that the order is different. If we were to just compare the two lists with a comparison in this way, we would get false because even though the numbers are the same in the two lists, the orders are different. And sometimes we actually end up in situations where we want to ignore the problem of the index of the order. And so one option to do that would be to convert them to sets, because if we work with sets, in sets the order doesn't count anymore. So as long as the two are converted to set before the comparison, now we are comparing sets and not lists anymore. There is no intrinsic order in those sets. And so Python just cares about the fact that they contain the same things. And another useful application of sets is to find common elements between groups. So in this case, like a class, this is again like brings back to memories like operations on sets that you were using in high school, like those intersection, union, stuff like that. So you can imagine you have three groups of, like here there's three people that have three groups of preferences in places where they would like to eat. You can question those preferences if you want, but that's not the point. The idea was to use sets to find the overlapping choice that could work for all the three of them. And so this would be a set intersection, okay? And so we could write, set would convert each one of those to sets. We can do this very explicitly by saying, like, I'll write the very full, like, long version, explicit version, and then we can see how we can do this faster if we want to. So mark set equal to Melissa set equal to, and Matthew set equal to, and this would be set of Melissa and set of Matthew. Okay, and then we could say something like common mark Melissa equal to mark set dot intersection, and this is like, what is this dot intersection? Anyone? Yes. So sorry. A method, exactly. So we were saying that there are those functions that we call on variables. It will be clearer not like in 2 lectures, but like for now, let's trust me on this. We can call those functions that are that we call from the variable. So instead of writing intersection of Mark set and Melissa set, we call intersection from one of the 2 sets. So we write Mark set dot intersection, and we give as input the other set that we want to intersect with. So now common mark Melissa would be the set of stuff that is in those 2 ensembles. And we can have in the same way, well, it's already 1, so, but in the same way we can say common mark Matthew mark set is intersection Matthew set, and then we can take basically the intersection between those 2. Okay, so we take the intersection between 2, and then between the other 2, and then there's intersection of the intersections. Okay, we could have done this in a like short, like instead of this is of course like a typo. Instead of doing this in several passages, we could have just said something like, well, let's not do it. This is I would say the most like readable way in which to do this. Like we assign variables that are the sets corresponding to the lists, and then we take the intersections. Okay, so this is all for the practicals of last week, but don't worry if you are not fully buying what you need those things for, because like the idea is we will keep building on top of those variables in the next lecture, starting from today. So you will be seeing like those things like used in more and more contexts, and all of this hopefully will make more sense today when we actually start not just looking at variables and variable types and how to represent stuff, but also to do something with the variables that we are putting together. So yeah, the idea for today's lecture is to talk about flow control. Flow control basically means, well, yeah. So first, just a couple of minor things, ending stuff on data containers. But yes, then flow controls, and flow controls are really the bulk of your programs. Means flow control means what are the structures that you use to automate all the operations that you want to be happening in your scripts for like either running your experiments or doing your data analysis. The real core of computer programs is the fact that you can create flows where you do things many times, you do things conditionally, you really control what's happening in the program. And if we have time, I also will like to start talking about like good practices for writing what you're like very minor things, but like things that you should have keep in consideration from the beginning when you're thinking about the code that you're writing. Yeah. So very briefly, two things that I forgot to say last time. I wanted to introduce a couple of useful operations that you can do on those data containers. There is a sum function that I wasn't mentioning that like very intuitively can take collections of numbers, for example, lists, tuples, or sets, and it can, if they are integers, for example, it can take some of those integers. Remember that when we have Boolean values, so trues and false, those Booleans can be considered as integers. So true would be 1, false would be 0. So the sum of a tuple that has true and false elements in it correspond to the number of true values that are in that tuple. Okay, so sum function is useful, and you will be probably using it already in the practicals today. And another very useful operation that you will potentially be doing a lot is to check if stuff is inside a list or a set or a tuple. And for this, we use in. And this is actually very readable in English. Like you can imagine you have a list that contains some numbers, and now you want to check whether one number is in that list. And the super readable operation that you want to do is one in a list. Okay, so in is one of those special words that Python treats differently. It is basically an operator that gives you a false or true value depending on whether this element that you are checking for is contained in that data collector. So you can do it with lists, and this is, I assume, intuitive. You can do it with sets, the same. With tuples as well, there wasn't an example. You can also do the same for dictionaries. But you remember that in dictionaries, we have two kind of groups of things. We have all the keys of the dictionary and all the values that are placed associated with those keys. So in a dictionary, you have like, I don't know, one key that corresponds to another value, to one value, and another key that corresponds to another value. And so when you use the in operator, you need to specify whether you want to check whether that operator is among the keys, whether that element is one of the keys or one of the values that is associated with the keys. So where do you want to look for that in the dictionary? And the way you specify where to look for is either checking the values. So this means check if 0 is in any of the values that correspond to keywords in that dictionary. So in this case, there is no value that is 0, and so this will be false. If we were to check for 1, this would be true. And we can check whether a specific keyword is in the keys. And for this, we check whether is in the dictionary.keys. So dot values to check in the values and dot keys to check in the keys. And yeah, hopefully like this is potentially a bit random now, but hopefully this will like the way to use this will get clearer as we start using those operations in real case context. Good. Yes. But as I was saying, like today, what I want to do is to start introducing what we can actually do with those variables, and I actually want to keep it very practical. So there are longer practicals today. I will introduce you some of those operations, and then there will be more time than last time to actually do stuff on your own, and like we will be around. So feel free to ask all questions that you're having on the exercises that you're doing, and also on anything that wasn't clear up to now. So yeah, many of you have probably coded already, maybe in other languages, and so are familiar with the concept of conditionals and iterators. If you're not, don't worry, we will go through them. When you write a program, many times you want to specify some conditions, or you want to do some operations multiple times. And so let's start from conditionals. Many times you have one part of your program that does not always run, but run only if some condition is met. I don't know, I have a script to run an experiment, and I want a screen to press, like to become green only if the subject has pressed the right button. Or I'm running an analysis, a data analysis script, and I want, I don't know, some pre-processing to be happening only if there is an artifact in my trace. But those are like very random examples. Basically, in every program, in every script, you will always find at some level some conditionals. So conditionals means we encapsulate, like we use in Python, it's very like readable in English, is this if condition. And the idea is we write if, and then we put any kind of operation that will give us a Boolean as the result, so a true or false condition. And then we put afterwards with an indentation. You remember that in the very first lecture we were talking about the importance of indentation in Python. Today it will become important again. So we have this indentation, which means that everything that is happening, like all the code that is preceded by this indentation is happening, is sent to the interpreter only if the Boolean condition that we specify at the beginning is true. Okay, so this is fairly intuitive. I assign a to be equal to 1, and only if a is equal to 10, I actually print equal 10. So if I now run this cell, nothing will be printed. If I now change the value of a to be 10, now this prints. Okay, it's very readable. That's hopefully. Remember that in Python, there's other languages. Actually, most languages have something like this. So this is just relevant for people who have been using other languages. In Python, we don't have to explicitly say when the block ends. Just everything that is indented is considered to be part of the optional block. Good. Obviously, like there we were just putting one condition, but you can imagine concatenating all the Boolean conditions that you want, as long as there is only one true or false that come out of checking out all the possibilities that were there. So here we are actually using two Boolean conditions that we are concatenating with and so this print happens only if A is bigger than 1 and B is smaller than 10. Okay. So in this case, it's actually running. In this case, it won't. Many times, together with this if, we also specify an else, which is code that is executed alternatively to the first condition. So if the initial condition is met, this part runs. Otherwise, and this we say with else, again, fairly English intelligible, we execute this other block that is inside the else, which in this case is a print of a different string. So in this case will be like A is checked, this is false, so this is not running. We enter the else condition and we print this. This would print greater. And last thing to know about the ifs is that we can actually put multiple comparisons inside the same if. So instead of just an if else, we can write if elif. Elif stands for else if. And so this basically means that first we do this comparison. If this comparison is false, we go here and we try this comparison. If this comparison is false, and we can put as many as we want. Like here I put one elif, but we could have potentially 20 elif. Not very readable, but you can potentially have it. And a final else, which means if all the previous conditions have failed and if everything was false above, then we are actually running that final thing. Okay? Good. So is this all clear for the ifs? I hope, well, in case you can ask. But yes, then I wanted to also look at the for control. Because for is also fairly essential, because for is what we use to do loops. So it's what we use to do things many, many times. You know, that's like one of the big strengths of using a programming language to do anything that you're doing, is that for computer programs, repeating one thing multiple times is free, while for us it's very tedious. And so in your scripts, you will probably be writing many, many times for loops, where a for loop means like the concept is for something that can be 1, 2, 3, whatever, can change value some number of times, repeat this operation that is contained inside the block. So in this case, for I in range 3 means for I equal to 0, 1, 2. Remember that like we stop 1 before in Python because we start from 1. Do this operation, which in this case is print I. Okay? So this means that Python is executing this content 3 times. Even though we are just writing a line, the interpreter is getting this line 3 times because of the flow control that is above. And for have like their peculiar syntax, so we will be digging a bit more into them. But just like the most basic thing that you do in general is to just, you know in advance how many times you will be doing something. I don't know, you have 10 subjects in your data set and you want to do an operation for every subject, and so you just type in range 10. And this means this will be happening 10 times. Okay, with this range and number, we can have something happening that number of times with a variable, which I am assigning in the loop, in this case I, but could be whatever other variable, okay? That variable that we write in the, let's say, beginning of the for loop is the variable that within the loop is valued 0, 1, 2, etc. So if I now run this without changing what I'm printing, what do you guys expect to be printed on the screen?
Error.
Sorry?
Error.
Get an error? Other options?
Nothing.
Sorry?
You print I 3 times.
Yes, what is I now? Guesses. You are not supposed to know because I haven't told you. 2? Yes, 2 is a good guess. So when the loop is over, we still have access to that variable. So like error was was actually a reasonable option. You can imagine that if I write this, I have access to this variable inside the loop. But then if I want to print this variable outside the loop, this variable vanishes. It's like in other programs this would be the case, but in Python this is not the case. After the loop, I still have the variable I, and the value of that variable is the last value that it had during the loop. Okay, so in this case it will be 2. Okay, so if I now write people, I will print 2, 3 times. So yes, remember, like this is important to know, because like sometimes you can like have bugs that, I don't know, you have a variable that was called people equal to a string, I don't know, like whatever, and then you use the same variable to be looping like for like in a loop. You will have changed the the value of that variable. You won't have the string anywhere in the program. So you have to be considerate about how you name the variable you are using in the loop. It matters. Okay. Is this clear? Okay. One very convenient way of using for loops is to do operations on all the elements that we have in a string. Okay. So you can imagine that you have a string, our favorite, a list of a list, in this case, a list of words. And imagine that you want an operation of each of the words that we have in this list. But this, like you can imagine, is a list of subjects, is a list of recordings, is a list of images, is a list of whatever you want to do operations on. And the very convenient syntax to go element by element in this list is, well, of course, there could be one solution could be for I in range len a list. Does it make sense? So I'm having an I variable that is 0, 1, 2, 3, whatever, until the number of elements that I have in the list. And then you actually want to extract each element from the list. And so I could write something like element equal to a list, square brackets I. Okay, in this case I would get values one by one from the list. And let's say that we print them. So at each iteration, we are taking one of those elements and we are printing. Now in Python, there is actually way more condensed way to do this, which is, and I would strongly encourage you to use it. For element in a list. So now we have this element variable that at every iteration is assuming the value of each element of the list. So now we are getting exactly the same result. So maybe it's, I don't know if in other programs like languages you do this, but it's a very convenient. It also once you get used to it, it reads very easily because you don't have to think about the fact that one is a number that then you use to index the list. You just looping, this is what I would refer to as looping over a list. Okay, so you have a list and you are taking element by element, so the values of that list.
Does it have to be element or can it be any random word?
Oh no, could be again entirely arbitrary. Element is the variable that the variable name that I was assigning arbitrary in that script. You could call it people as well.
So it's whatever's between the for and in.
Exactly. Whatever thing that you type between the for and the in, that will be the name of the variable that you're using inside the loop. Okay. There are some times where you actually also want the number, you want to know at which point of the list you are. You don't care just about the word. So you can imagine that I want to print not just the word, but also know which is the 0 word, which is the 1 word, and the first word, which is the second word, etc. And so the way I can iterate over, the way I can get both a variable that marks the index and a variable that marks the element in the list is with something that is called enumerate. So with enumerate, I'm actually, now I can put two variables, not just one. Before I was just writing, was just writing elements, so one thing. Here I'm writing index and word, but again, this could be index and people as well. Those are entirely arbitrary names that I'm giving. And if I write enumerate here, this means that the first of the two variables will be valued 0, 1, 2, 3, 4, as if I was writing a range, in range. While the second element is actually the content of the list. Okay, so this is a very convenient way if you actually need to have both the values of the list and the index. And there is one final kind of trick over iterations that might be useful to know, is this zip function that allows you to basically zip together multiple lists that you want to loop over and to go through all of them simultaneously. So just imagine I have a list of words and a list of numbers that is the same length of that list of words. I can write for word number in zip this list and this other list. And this means that word will be first A, then simple, then list, while number will be first 10, then 30, then 42. Okay, so this basically means that we are simultaneously looping over multiple lists. So if we print word, if we print number, okay, so if you have to go through multiple things, you can do this. Of course, this is not like necessary. We could also always write for I in range lang a list of words, word equal to a list of words I, number equal to a list of numbers psi. Okay, this would be the same, because the other one is another list of numbers. This would be equivalent. So this zip, like you can remember, it doesn't really matter. You can figure out a way of doing it anyway. Okay, and remember that those operations that I just mentioned, like we were using lists, but you can imagine going through all the things that all those data containers, they are all, the word is iterable. So you can go element by element. Iterable means that you can go element by element through it. Basically everything that is containing multiple values is iterable. So strings, so the lists are iterable, the tuples are iterable, the sets are iterable. If we want to iterate over dictionaries, in the same way as we were doing before, we want to write, do I have it? Yes, so if we want to iterate through dictionaries, we want to specify whether we are iterating over keys or over values, okay? We can go one by one through all the keys of the dictionary or one by one through all the values of the dictionary. So yeah, in this case, we are going over values. In this case, we are going over keys. And oh yeah, and actually with dictionaries, we also have this dot items that allows you to go through both items and keys. But you don't have to, like, as long as you remember one, you can also always get the others. Like you can also just say for key equal to edit keys, you can always write val equal to edit key. So you can always just iterate through keys and use the keys to get the value. It's key without the S. Okay. Okay, the last thing that I wanted to show you before we go to the practicals is another construct that can be fairly useful to like make readable code, which is what is called list comprehension. Okay, a list comprehension is basically a way, many times when you do for operations, you are doing some operations and then you want to store the result of whatever you were doing element by element. And usually the way you do it is you put those stuff in a list. So just imagine I want to, like, I have a list of words that is like the split from this list of words. And I just want to, I want to go through all those words and I want to parse the first letter for every word. Okay, so the naive way of doing it would be initialize an empty list and then say for word in word list first letter dot append. You remember this append method is the way we can add new stuff to a list. And here we can say word 0. So word 0 is takes the first value of the word string. So the first letter of that string. Okay. Which is fine, but there is actually a much shorter way of doing it, which is like the list comprehension syntax for it, which is we directly write in between the square brackets that we normally use to define lists. We write inside those brackets the loop that generates that list. Okay, so first letters equal to, between square brackets, word 0, so index the first element of the word variable, for the word variable in list. Okay, and this is a pretty powerful way of generating very quickly a list out of an operation that is repeated many times. Okay, and this is like in Python. You also, if you read, like maybe at the beginning you don't use it that much, but the moment you start reading code that is being written by others, this is something that in Python is used a lot, because like actually those operations, like we don't get into that, but keep in mind that when you are writing a list comprehension, you are also making the loop more efficient. You can even have conditions inside this the list comprehension. So, well, let's first do it in full. So just imagine that you want to add the first letter only if the word is long, like above 3 letters long. So the way you do this in a loop would be for word in word list. We write a conditional. So if word len of word is bigger than, let's say, 3, random number, first letter dot append word 0. Okay, so now this will be entering this block and actually append the letter only when this condition is met. So if the word is too short, we are just skipping that word and going to the next one. We can check this out. So we could even do this in a list comprehension by writing first letter equal to list word 0 for word in word list if len word bigger than 3. Okay, and this is pretty. Actually, also it reads reasonably well, as long as it's not humongous. Like at some point, if you write too much stuff, you cannot read it anymore. But when it's like fairly small part of like piece of code, this is very like sensible to use. Yeah, readability counts. So if you start having more complex situation, like I won't get through like this randomly complicated example, but if you can write incredibly long and complex list comprehensions to do stuff if there are like multiple conditions, and like you can make those too complicated, and at that point probably you don't want to use a list comprehension anymore. Like the moment you cannot even read your own code, like me in like at the moment by looking back at what I did some hours ago, that's probably not like a circumstance where you do not want to use a list comprehension and you just want to write. But in this case, there is a, well, maybe it's unreadable for you as well, but if you get used to Python, like this, like do this explicitly, so like the loop and then all the conditions and nested conditions inside the loop actually usually reads better than the list comprehension. But as long as the list comprehension is short, I would encourage you to use list comprehensions because they are convenient. Yes?
Do you think it makes sense to use list comprehension to filter things out of a list? So for example, some list equals, and with the list comprehension you do item for item in list.
Yes, yes.
If item pulls in another
Yes.
list.
Yes, I would do this.
It's like doing the intersection between sets but with lists, right?
The intersection, sorry?
It's like finding the intersection between two lists. But you don't
Oh,
have
yes,
the
yes, yes,
intersection
yes.
between them.
So what Matteo's suggesting is like potentially a good application would be similar to what we are doing with sets. Like without using sets, you can have a list of stuff equal to 1, 2, 3, 4, another list equal to 3, 4, 5, 6, we could potentially find easily, like instead of using sets, we could find the common, like we can take stuff from a list only if there is in another list, if that thing is in another list, by writing intersection equal to list comprehension. Are you, well, let's go to full screen again. So intersection equal to, are you all reading? Okay, no, I hope that by this far in the class. Okay, so we can write the element for element in a list of stuff. If anyone wants to suggest? Be brave. So what we want to check is whether the element variable is contained in the other list. Okay. So remember the conditional that, like the condition that we were seeing at the beginning of the class to check.
In another list?
Yes. So intersection would be a set operation. Here we are writing basically we have decided that we do not want to use sets for reasons. I would actually use sets here, but doesn't matter. We are just doing it for trying, for fun. Yes, in. So we can say if element. So if this variable that we are looping in a list, another list. And we can check out intersection, and it's actually the intersection. Okay. Okay, good.
Okay, why wouldn't you use intersection there?
Sorry?
Why would you not use?
Oh, no, for like, I would actually use intersection. It was just as a.
You can do either.
Sorry? You can do either, yes. Actually,
I usually forget the sets exist.
yes, exactly. Like people tend to forget that sets exist, but I do encourage to use sets. For intersection, I would definitely use sets instead of writing this. It was just like to see how another option for doing this. You can imagine maybe you add more complex conditions, so you could do this in a loop, but maybe not in a list comprehension. If you want to complicate the condition, maybe you want to write a full loop. But like maybe you want to do something else apart from like not only is contained in the other list, but also, I don't know, bigger than a number or like even or whatever. So this gives you the flexibility of adding other conditions if you want. Yup. And very last thing before the practical, actually one final thing again on this list comprehension. Together with list comprehensions, we can also do dictionary comprehensions, which is exactly the same concept, now mapped onto the dictionary data container. So remember that with a dictionary, we need to write the key and the value, okay? And we do this in curly brackets instead of square brackets. And so the dictionary comprehension, in this case, the idea is we want to we want to do what you were doing in the exercise of writing a dictionary that contains the length of all the letters, of all the words in a list of words. Okay, so one way of doing this in a loop, like starting from an empty dictionary, would be, let's say, word len dic. So one option would be we start with an empty dictionary and then we loop. We say for word in word list, dictionary word equal to len word. Okay, does this make sense?
So is it going to give you the length for each word?
Sorry?
What's this going to give you? The length of each word.
Exactly. So this gives us a, So this gives us a dictionary where for every word we have the length of that word. Okay? We could do the same operation in a dictionary comprehension. Okay? So exactly like we map the same concept that you just saw for lists. We can say something like word, and in this case, this will be my key, like the key of the dictionary, colon, len word, and this will be the value of every element in the dictionary for word in word len word list. Okay, so we have like in one line we have defined a dictionary and we have filled in that dictionary via this loop operation. I look at a lot of discombobulated faces.
Why would this be useful? Like, when would we use this?
Basically, every time you want to initialize quickly, like you want to fill in, like this is obviously a very kind of toy example, like this specific word length, but you can imagine that ideally you want to use dictionaries for, I don't know, you have data that you collect as, I don't know, you have subject ID as the key of the list, and some data as the key of the dictionary, and you have some data as the value of the dictionary. You can very quickly fill in another dictionary with operation, like with like some information about that data for every subject, and you still want and you want that to still be a dictionary, and so you can populate this other thing very quickly by just writing this, which is a one-liner. It feels like it's very contained because it's one part of the code where you are creating this thing.
Yeah.
It is a bit more efficient than a loop. So basically, every time you are generating either a dictionary or a list in a loop, because you need to do some operation to fill it. That's why you would do it in a loop.
But you know, because it looks quite messy, the output. Like, it doesn't look like a table.
So you can.
Oh, you mean this? Oh, well, this will be like this thing below is like we will see how there are other actually more elaborated data structures that would format the output as a table. Like there are ways, like more other data types that would format the data as a table.
If you are used to MATLAB, typically it is exactly similar to the structure of MATLAB, basically. So it encodes exactly the same way the information as the structure in MATLAB. So whenever you have this like MATLAB file that you tend to save and everything, for Python the equivalent would be to use a dictionary. And again, we'll see that with Panda and Seaborn that uses this input to make it like in a decent way. So if you want to plot a figure, usually you would use like a subset of your data set, and you use definitely this kind of tools to input it exactly the figure that you want with only the data that you're interested in.
But anyway, the way it looks, it depends on your. It does not depend on Python. That depends on your IDE. So here we are using Jupyter Notebook and these slides, and it looked like that. But if you were to code in like Spider or like with other interfaces, you would see the dictionary represented in a different way. Like the representation is different from, like the way the monitor show you the variable is different from how that variable is represented in the computer. Okay, so that's what I'm focusing on. Okay, good. Now there are some practicals where hopefully the most confused among you could like try hands-on to play with those things, and obviously we will be around. So if you were missing things, feel free to like stop us and ask everything that you want to ask. You were asked to check whether this number was even or odd, and the way to do this would be with the modulo. So if this number modulo 2 equal to 0, this means that the remainder of the division by 2 is 0, and so this is even. Otherwise, we just print odd. Okay, and now we are missing. Okay. Then you were asked to check for palindromicity of this word variable, and like this was a bit tricky if you were not remembering that with strings we can actually index them as we do with lists. So we have a way of index this word that so that we can take, I don't know, one word every 2, and like this you didn't know, but I was telling you, if you actually write -1 as the step, you actually go in reverse order, which in this case gives the same word. So we can write if word equal to word reversed. Now this was palindrome. I might have a typo. I don't know. Doesn't matter. Okay, good. Then you were asked here. Actually, we're asked to ignore this part of the code because, also in some exercises, you will also in the future you will see parts that you actually don't necessarily need to understand. So, and that's the idea. You have to understand what you need to understand. And that is not necessarily always all the code. So in this case, you didn't care about how I was giving you those values. You just cared about the fact that there is a variable neuron trace, which is a list of zeros and one, where one is action potentials, and we know that this is data for 1 second for this neuron, and we want to compute the firing rate, which is number of action potentials per second. And so here, basically, the task was to just count how many ones were in this list, and this we can very easily do by some neuron trace. Other options with for loops were also potentially valid, but this was the neatest way of doing this. We can assign this to firing rate variable equal to sum. Okay. And then I was asking you to write a conditional to check whether this firing rate was high or low. And so firing rate equal to, and here there were some arbitrary numbers, print high firing rate, if, and here the idea, well, actually there's different ways of doing this. We could write, we could start in order just to have, so if lower than 5, we can write low firing rate, if firing rate. Actually, we could either here we could write something like firing rate bigger than 5 and firing rate lower than 10, but remember that if firing rate were smaller than 5, we would be already entered the for conditional here. So we actually, this we actually don't necessarily need, okay? Because this is already implying that we passed with a false the first statement. We don't need to, yes?
Can I do if 5 minor than firing rate minor than 10?
You mean concatenating something like this? I don't. Oh yes, you. Is this doing what we wanted to do? Yes. Okay. So you can. Yes. Okay, but again, it would be redundant in the elif because we already checked for one of the two conditions above. Print here. Else stuff.
Is it not like a Boolean operation then?
Sorry?
Will you not compare a Boolean operation with interpreting the first comparison as true or false and then compare it with the second one?
That's what I was fearing, but apparently it works. For the values in between, it's, I don't know. Usually, the way, to answer the question, I always try to make this as explicit as possible. So I would write one condition and the other condition, just in case. Okay, good. And then, well, there was this last bonus question for which I will post the solution in the next week. But let's have a look at the 4 exercises. So, we were asked to split this word in a word list. So essence.split, and this would give us a list of words. And now we wanted to put in this long words list just the words that were longer than some length, which I think was 3. Okay, and this we could do just by initializing the long word list as empty, and then say for word in word list long words append actually, sorry. We have to put the condition if len word bigger than 3, word list dot append word. Incredibly complex calculation, apparently. Don't know why it's taking so much time, but this should be correct. Why is this lagging? What happened? Oh, I am asking it to explode because I was basically making a list to which I was adding elements at every entry in that list. So I was basically keep appending stuff, and so it could have gone on forever. So it's long words what we are actually. See, like Python is very gentle in like letting you do very stupid things. You should be the one knowing. Okay, so this is actually just the long words. Hunter? No.
Yes,
Yes.
it's a great question. Could you maybe expand a bit on what the thing between for and in is? Because I think that there was some confusion as to whether it was an index or the actual.
Okay, very good point. So especially for people who have been not spoiled, but like ruined by MATLAB usage, let's say. MATLAB and other languages have this very ugly way of doing. No, kidding. But maybe you are used to looping with just with numbers, like indexing. So you would always say something like for I and in Python, remember that if you want to go just with a number, like the basic way of looping just with numbers, you always have to say range. Okay, and if you want to to go through a full list, and you don't want to type manually the length of that list, you want to go range of length of the list. So let's say word list. Okay, and like in this case, I will actually be a number, and if we want to get the word, we would say, let's say. Sorry, I have some selection problem. Let's say word equal to word list I. Okay, and this is legit, like ugly but legit. It will work. If, for example, for any reason you actually need the I, like this is something that you could do. What you cannot do, and it's probably an error that you will be doing often because like it's very often it happens to forget the range. So maybe you just write something like this. But here Python complains because basically this would be the same as writing this. And the problem is that 10 is not something that you can iterate on. Okay, so there you have to put either a list or this range, and you can imagine this range as if they're like, you can imagine that range 10 is basically producing a list of 10 values, and Python is going through all of them. Okay, imagine that this is what range is doing. So if you want to go through numbers, you need to put range. But in Python, the way you would normally iterate over a list is just to say word in word list, where now word is a variable that is directly assuming the values that are inside the list. And this can be confusing at first, but it's actually a very reasonable way of writing this, because you don't have to redefine something inside there. You just have, most of the times you do not necessarily care where you are in the list. You just care about the current element that you're doing the operation on. So this spares some space. And remember that if you want, you can actually have both the number, like the index, and the value using enumerate. So in this way, we can actually have both. Don't need this anymore, and we can just say print I word, and this gives us both. Okay. Yeah, and here the idea was to do the same with the list comprehension. So you have to remember that you, instead of writing empty list and then appending stuff, you can just use list comprehension to say word for word in So in this list comprehension, like basically this part is the loop for word in word list, and this part that precedes the for, maybe we have not expanded on that before, but the idea is like this part before is what we are actually putting in the list. Okay? So we are putting in the list, in this case just word, so the whole word, like the whole element in the list. For word in word list, so this would put all the words. If we want to just select some, we need to put a condition. If word, if lang word bigger than 3. Okay. And in all of this, the fact that I'm writing word is entirely arbitrary. Like the same could have been written saying a for a in word list if length of a is bigger than 3. Okay, entirely arbitrary choice of variables, as long as I'm always using the same variable. If I were to write something like word for a in blah blah blah, this will always put the same variable because I'm not redefining that word inside the loop of the list comprehension. So either I already defined a word variable before and I'm I'm just creating a stupid list that has like some number of repetitions of the same thing, or if I were not defining the variable word before, Python will complain about the fact that it doesn't know what word is. Okay, so here usually we actually use the same, like we do something like not necessarily like here we are just putting the word, but we could write something like this if this was a list of length of words, or we could take we could do some indexing on the on the variable, like we could do stuff instead of putting just the word. Okay. Okay. So here again, you needed to understand that you didn't necessarily have to understand what I was doing here, as long as you were getting that neuron traces is now a list of neuron traces defined as we were defining them before. So each element of this list will be 1,000 element values, either 0 or 1, where 1 is when there is an action potential. But if we actually want to just peep inside what's happening here, we can see that I'm defining this variable as a list comprehension, where I'm looping 10 times for I in range 10. Forget about this, you don't have to care, but you can imagine that this was something like this. I'm looping 10 times, and I'm calling this function that is generating this random data that you are playing with. And so at every time that I iterate, I'm generating a list and I'm putting it as the element of this list comprehension. So the result of the list comprehension will be 10 elements list, where each of the element has 1,000 values that are either zeros or 1. Okay, an easy way to check that they are all zeros and 1. Anyone? If I want to check what are the possible values inside the lists.
Can you put less than 2?
Sorry?
Can you put less than 2?
That will just tell me whether they are... No, I want an operation that gives me all the different elements that are in the list.
You might use the if.
I could write something with an if, but there is a super simple operation that I can do.
That he likes a lot.
That I like a lot.
Enumerate.
So you remember that there was a data collector type that was dropping duplicates.
The union. No.
Unique.
I getting there.
Getting there?
Somehow people forget about
Set.
Yes,
Yeah.
exactly. So if we just convert this to set, we can see that this is a set. Like there were 1,000 elements there, but all those 1,000 elements were just either zeros or 1. And the easy way to check for this is to convert this to a set, where now we just care about the different things that are inside there. And this is just 0 and 1. I mean, minor and not relevant. Yeah, then the idea was to compute the firing rate. So let's say the extended long version of doing this would be, we want to iterate because we want to compute the firing rate for every neuron. So we will iterate in a way like for neuron trace in neuron traces. And note that here we don't care at all about the in the position where we are. So in this case, we do not want to do range len. Like this is the clean way to go. We already saw above that sum was the operation that we want to do to compute the firing rate. So we can say something like firing rate equal to sum.
It's in not neuron trace, but firing rate.
Oh, sorry, neuron. Oh, neuron traces. Okay, I'll type. Okay, so but now firing rate is changing times, like changing value 10 times, and we are not actually keeping track of the value for all single neurons. So if we just look at what's happening to firing rate, it will just after we leave the loop, it will just have the value of the last element in the list. So actually what we want to do is to keep track of all firing rates, and one way of doing it is to put them in a list. So we can initialize an empty list and just say firing rate dot append, and at every entry we append the value, so we can actually oh, this I didn't have to change. Okay, and this is those are all the firing rates for all the neurons. But you can see, like for example, in this case, this is an operation that could be way more concisely expressed with a list comprehension, because like it's super simple operation and just computing the sum of a list. And so I would like, this is for me the perfect case where you would normally, like in your code, you would write a list comprehension where just say firing rates equal to list comprehension of some neuron trace for neuron trace in neuron traces. Okay.
I think that the exercise above was to just calculate the average, and
Yeah, the right code in the wrong cell, basically.
Sorry. Okay, so we had to compute the average of this, and so the average would be just like sum over length. Okay. Okay, and yeah, actually, yes, computing also the sum in one line would be, I mean, we could write sum, like, I would never do something like this, but we can potentially write sum of the whole list comprehension and then over length neuron traces. Which, sorry?
I did it too.
Yeah,
I thought you were asking for
you can. Sometimes I ask you to do stupid things. It can happen. So in this case, like this would be very ugly code. Like it's super long kind of line. So it would make much more sense to actually write firing rates. And this is just a variable that contains all the firing rates. Not select. And then we can just, in another line, more reasonably write some firing rates over firing rates. Okay.
Readability counts.
Sorry? Readability counts, exactly. Good. What time is it? I'm happy to, like, if you guys want to rush, otherwise I'm happy to keep correcting. Shall we? I mean, I think it will be pretty short. Yeah, last two. So let's just keep going. Okay. Next part was like using the concept of dictionary comprehension. Basically, doing the same operation that we were doing here, but we want to. Well, let's do it with and without dictionary comprehension. So the idea is we want to not just make a list of firing rates, but we want to create a dictionary of firing rates where to every neuron we give a key that is like neuron 0, neuron 1, neuron 2, neuron 3, whatever. And so the idea is we can initialize a firing rate dict. We can initialize it empty and then say And in this case, we actually do want to have a variable that is 0 the first time, 1 the second time, 3 the second, 2 the third time, etc. So in this case, we actually want both the content of the list and the index that you would normally use in MATLAB. Okay? So this is a perfect case where you want to use the enumerate, because now we can write for I neuron trace in enumerate neuron traces. Okay, so now I will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and neuron traces will be neuron trace will be the list of the first neuron, the list of the second neuron, the list of the third neuron, etc. And so we actually want to put inside this list firing rate, inside this dictionary firing rate. So as the key of the dictionary, we want to create a string that goes neuron underscore number, and there are multiple ways of doing this. We can actually define it as a set, like we can write something like, we can define the key string that we will be using as the key for the dictionary. And this could be something like neuron plus I, string I. This could also have been something like f, if you remember the syntax, neuron underscore I. Alternative, perfectly valid alternative. Okay. So now this is the key that I want to use in the dictionary. So dictionary key equal to, and here I put neuron trace. Okay. So the way to do this in a dictionary comprehension would have been firing rate dictionary equal to curly brackets, because this now we want this to be a dictionary. Curly brackets of, remember the logic is key value for whatever in whatever. Okay, so we actually want to keep using enumerate, because we want both the index and the value. So we want this in to be the enumerate. We want I neuron trace to be the values here. Okay, so for I neuron trace in enumerate neuron traces, the key is this. And now, like when you use list comprehensions, you don't have space to assign intermediate variables, so we have to do everything in one go. So the key will be this, and the value will be this. Okay, and this starts becoming a bit of a complicated list, like dictionary comprehension, that I would probably not qualify as very readable, but in principle, this is what you could be doing. Okay. So also reading code at this magnification is probably in general not great. But yeah, the idea is dictionary key value for, in this case, we have the enumerate condition. I don't know, matter of taste. Okay, and then last exercise, we wanted to filter those values to create a list of all the neurons that have firing rates bigger than 5. And the idea is we want to create a list with the key, like the keys of those neurons, with the IDs of those neurons. So we want to have a list that is like neuron 3, neuron 5, neuron 7, like all the neurons that have a firing rate above some value. And so, well, we could either write for neuron ID in firing rate dictionary dot keys value or firing rate equal to neuron ID. This was one option. We could also write something like for neuron ID firing rate in, if you remember this, items. And items immediately like loop over both the keywords and the values. So we get two variables, neuron ID and firing rates, that are the key and the value of every element. And so we want to write like high firing rate list. We initialize it empty. And we put here if firing firing rate bigger than 5, what was it? High firing rate list dot append neuron ed. Good. And now here, so here we just get a selection of the neurons that were high firing rates. And now, very last thing, I was just asking you to check if neuron 5 was in this list, which was to be done something like neuron 5. And actually we want, like neuron 5, we want, all those are strings, so we want to define this as string in high firing rate list, and this is true or false. Okay. So, like, feel free to, if you want to go over everything together at home, I will be posting the solutions during the week for what we corrected until now. And yeah, today we did a lot of practicals. I think it was making sense for you to, like, those are the very basics, like the fundamentals, let's say. So don't worry if you're not remembering everything. Like, the growth is exponential usually at the beginning, because like there are many of those concepts that we will be constantly drilling. Like next lecture we'll be seeing functions, but you just add a little concept with functions, but the code that you keep writing is always stuff that is like conditionals, for iterations, lists, dictionaries. You will have time to like drill those concepts. So don't worry if you weren't, like, I think no one there were a lot of practicals, so don't worry if you were not getting to the end. Okay, good, great. Sorry for keeping you longer, and see you next week.